It's almost like this is a real YouTube channel now.
Yeah. So welcome to our demonstration on how to do while loops, random number generation, concatenation, and incrementing. I don't actually talk like this, you guys. It's okay. I'm just going to do it like a normal lecture. Everyone in the room is like staring at me funny. It's okay. This is where I ask you to smash the like button and subscribe. Leave a comment down below. Yeah. Also, comments are disabled on my channel so that you all can't rip on me in the comments. So, whatever, I don't care. Okay. Yeah, link in description. 500 free V-Bucks if you Fortnite. Okay. All right, so what we're going to do is part of what we're going to include today is random number generation. So you guys know that we have to include the library for scanner normally in our programs. We are going to include the random library, the random package as part of the library, which is different than the scanner, but it's not fundamentally different. We're going to go import java.util. What do we normally do? Scanner. Wildly different this time. Random. Yeah, that was random. Okay, so we have java.util.random. It's underlined warning because we haven't ever used it. Unused import, we'll get there eventually. But just include that at the beginning. Okay, we are going to morph a few things. We're going to write the program, then we're going to change it just a little bit, just because I want to show you guys some examples. You guys know how we usually work. We are going to declare our integers. Okay, right here. We're going to need two integers to begin with. We're going to go int, and we're going to go count is our first one. That's going to be our variable that counts how many times the loop's executed. Generally speaking, you guys, our counter variables are usually named one of two things stylistically. You can name it either count, or you can use the I, just I. The reason they use I is because it's short for incrementer, but, you know, whatever. For this one, we're going to use count. Here's another quality of life thing that I haven't taught you guys yet, but I'm going to show it to you today just because it's good. I know I make you guys do things the hard way first and then let you do them the easy way. Here's the easy way is if we're going to declare 15 integers, we declare int count, int number, int A, int B, int C, right? You don't have to actually do that. You can go comma, number, like that. That will declare both of them, both count and number. If you would like to continue to individually declare them, that's a style thing. You can totally do that, but this is kind of a shorthand way to reduce your line count if you're worried about that for your code. Okay, all right. So here, we now have our counter saved up. Let's write our while loop. So we're going to go while, and this is structured just like our if statements have been previously. So while, and then inside of our parentheses is our condition. So our condition for this time, let's just screw off that and do count. While count is less than, 25, say, okay? While count is less than 25, don't forget, we need our curly brackets as our bucket to include our count, our while loop. Okay, we have a problem. Count is underlined in red, correct? If we hover the error, it says variable might not have been initialized. From our vocabulary unit, you guys know that initialization means to give the variable an initial value. What it's saying is this variable doesn't have a value, so how do I know if it's less or greater than 25? You don't. So we're going to give it an initial value. I'm going to make it 0. Count equals 0. When you initialize your variables, you can initialize them as whatever you want. If we wanted to, we could make this 526. But most of the time, you're going to find that it makes the most sense to start at 0. Okay, so we're going to start our count at 0. We're going to print something out. Let's go system print. Let's go print line, so it puts it on a new line. And then let's go inside of our parentheses. Let's just print out the count. right? So we can see what it is. This is just an example of what's going to happen. Okay, if I run my file, boom. So that's a thing. What's it doing? It's making unlimited zeros. How long is this going to go on? Forever. Why? We never told it to do anything else. If you look at our loop, count can never adjust, and so it's always going to be 0, and 0 is always going to be less than 25, which means we are in something called an infinite loop. This is bad. Okay? Okay. This is bad. Go ahead and hit the stop button, and it'll kill your program. Okay? What's up, Nick? How bad is it? Well, it clogs memory up. You guys know when you have web pages that for some reason just slow your computer down until you close them? This is actually similar to kind of what happens in that respect. Now imagine all our loop was doing was creating just printing a number. Imagine if our loop forked off another process, and every time the loop repeated, it forked off another and another and another and another. Eventually the computer's going to crash, right? Because we run out of memory. This one doesn't do that, but it wouldn't be that hard to set it up. So fundamentally, our error is in the fact that count never changes inside the loop, so it's never going to get better. So classically, what you guys have done when we've added 1 to a variable is we would go count equals count plus 1 like that, right? So that's going to take the current value of count, add 1 to it, and then save the new value back into the variable of count. But as we have discussed in the past, programmers are some of the laziest people in the world. So clearly that is way too much for us to type, right? Hand on forehead as I sigh about how difficult my life is because I have to type that. We can just do this instead. Plus, like that. So what this does, count plus plus just says, hey, whatever count's current value is, all I want you to do, add 1 to it, and then save that new value in the variable count. Okay, so what we have now is we have the while loop should run the first time it's going to run, count is worth 0, while count is less than 25. Is count less than 25 right now? Yeah, it's 0. So it's going to print out a 0, and then it's going to add 1 to count. Now let's just pretend that this is executing. So count is now worth 1. We go back up to the top of the while loop. Okay, count is now worth 1. Is that less than 25? Yes. So then it's going to print what? 1. And then it's going to go up to 2, go back up. We're okay. So essentially what this should do would be to display 0 through 25, right? Maybe not. 24. Why did it do 24? Because it said less than 25. If I needed it to include 25, what would my change be? Less than or equal to 25, right? So we can totally do that. Because remember, there's a bunch of different conditions we can evaluate. Less than is simply one of them. We can do equal, greater than, not equal, which is actually really, really handy, as it turns out. Okay, let's change this. Let's put something in front of our print line. Let's generate a random number. So our random number, we're going to save that in a variable, just like your scanner. You guys know how when you type something in, you save it into a variable? Same thing happens with our random number. So we're going to use our variable number, and we're going to say number equals, okay? Oh, crap. Oh, shoot. Do you guys know what I did when I just said crap? I made our video rated PG. Uh-oh. Actually, then I said shoot, and technically that's a swear word replacement, so that makes it PG too. And then I just said it again. Oh, man. Yeah. It's okay. Yeah. Yeah, you got to be careful. I'm going to get demonetized. No, I'm not going to demonetize, but the school district only allows me to record things in G rating, but now we're PG, and hey, live life dangerously. Okay. We have to declare our random. You guys know how we declare our scanners usually? We have to do the same thing for random. Like we have our scanner, and I usually call mine reader. Like when we declare our scanner, we set that up. We have to do the same thing to random. So instead of scanner, what do you guys think we might type? Oh my heck, y'all are geniuses. We're going to go random, and then we have to give our random number generator a name. I'm going to call mine Randy, because Randy's a nice guy. Random Randy equals what? New random, like that. And then in our arguments, what do we put in there? What do we usually put in on our scanner inside of our arguments? Nope. In our scanner. Max, you just about said it. Let yourself answer the question. Don't worry about being wrong. System.in. Who said that? Molly, did you say that? Killing it. Okay, normally we would put system.in because the scanner reads from the system input. We don't need to do that with random. We don't have anything that we're going to do here yet. So we're okay. So we're going to say number equals, now we're going to call it Randy dot next int, right? Still very familiar to you guys, right? Should be. And then in our arguments, this is where we put the range that we want it to generate the random number from. If you leave this blank, it will literally generate a random number between 0 and who knows. Turns out it's somewhere around 2.1 billion, but still. Okay. It actually is going to generate a negative number, but we'll get into why that happens in a little bit because we're going to force it. Okay. Let's go ahead and do 100. So it's going to generate a random number from the first 100 numbers. Okay. Now it's going to be system.out.println, but I don't want to print count. I want to print the random number. So we're going to print number right there. And now when we run this, what should happen is our while loop is going to execute how many times? 25. So it should generate 25 random numbers between 0 and 100, right? So let's run it. Hey, well done. 98. Hey, I got 98 twice. Somebody got a negative number. Who was it? Own it. Own your mistakes, man. If you got a negative number, it means you did not include the range properly right here. That's okay. Not as stressful. Don't worry about it. Yeah. So you're here. Okay. So that's kind of cool that we can generate random numbers now. We're generating random numbers between 0 and 100. But that's not really what we're going to try to do this time. We're going to try to do something else with it. So let's tweak this just a little bit. I am going to take my output. Let's go ahead and grab this output and let's move it down outside of our while loop because I actually don't want this to run every single time. I need to tab it over so it's vertically aligned with the rest of my code. Except now I have this problem, right? Number might not have been initialized. Okay, so let's initialize number. Why didn't it say number was not initialized inside of here? Did you guys notice that? Check that out. When I move it inside of here, the error goes away. But when I move it outside of the while loop, the error comes back. What was that, Miley? Okay, Miley says, is it because of the 100? Yes. So what happens when the while loop runs? What happens to number? It gets a value, right? Every time the while loop runs, the number gets a value. But do while loops have to run? Is there a chance that this while loop may not run at all? Yeah, because while loops, the condition doesn't have to be true. And so what the compiler is saying is, if this doesn't run, you're going to use this variable, and that variable might not have a value, and frankly, I don't really like that. So once it's out here, it's going to force us to initialize it, so we're just going to start it at 0. Not really a big deal. 0 will never actually be used because our while loop is going to run, and then it's going to be overwritten, and then so what? Can I put 0 for both of them? What do you mean? Yeah. Yeah, totally. You can totally have them be the same number. Okay. So now we have a random number that's going to generate here. I want to change the condition of our while loop. This is what I want to do. We're going to go while number is not equal to 87. Gussie, what's 87? That's my racing number. I use it for everything. I don't know if you guys have noticed this, but in your grades, I literally never give anybody an 87. I'll just give you an 88. If you earned an 87, I give you an 88. Because 87 is the best number, and 87 is not the best grade, and so I can't have somebody with the best number that doesn't have the best grade. So, yeah, I know. Foibles, right? Okay, so while number is not 87, this is going to run until the number is 87, right? So what's going to happen is this while loop is actually going to count how many times it takes us to spin this number. So let's say Gussie did, I don't know, 50. Okay. You could put any number in here that you wanted. For me, I do 87 because that's my number. Okay, so it's going to count how many times it took to generate the number 87, because as soon as the number is equal to 87, all of a sudden, bam, it dumps out, right? And we go there. Okay, so we're going to get rid of this number down, and we're going to do an output. So we're going to go quote, okay? So we're going to say it took, okay? And then we're going to concatenate the string, plus count, right? So it's going to output the value that count holds as a string, because that's what system.out.println does, is print strings. Okay, it took that many rolls. So let's put that in here. Oh, we got to add it. I forgot to concatenate that. Okay, it took rolls to get 87. Okay, so now it took. So do you see how this is 3 separate strings? Each one of these is 3 separate strings. Classically, to this point, I've been making you guys system.out.println for each one of these. You don't actually have to do that. You can concatenate them into a single string. Okay, so if I run this, it's going to say, boom, it took 7 rolls to get 87. Anybody beat me? 270? 285? He can't roll. Why not? Look at your loop. 1 roll! Okay, does anybody have higher than 285? 341. 415. 584? Holy crap. All right, so someone in our class, right? Xavier, what did you roll? It took 1 roll. How many rolls did Xavier's program do to get his number? Did it take 1? Okay. If his program said it took 0 rolls to get 87, how many would have it actually taken? 1. Okay, so we have a problem. If you look back at your code, right? So the first time our loop runs, what is count worth? 0. So if we want it to report correctly, we actually would have to change this to 1, right? Because now the first roll. So Xavier's thing actually took 2 rolls, right? Because the value for count was 1, which means that was actually the second time that it rolled. Okay? Actually, so during first period yesterday, somebody took 0 rolls and everyone got confused. Okay? So now, if we run it, I'm going to do this. It took 16 rolls. That's not bad. I don't know if you guys know this, but in your output window, you can actually click this green thing and it'll rerun it. 102, 98, 7 again. Wow. 5. 190, 140, 147, 53, 8. I cannot get below 5. All right. Okay. If we go like this and just go, boop, and I make it 1,000, and I go back to execute it, that number's going to go up, right? Holy cow, 5,000. 87 rolls to get 87? Rock on. Amy automatically gets the winning roll. Okay, 86. You were 1 point away from perfection. Okay, check this out. Okay, so 1,000 works. What if I do 100,000? $40,000? Oh, geez. 381,000 rolls. All right. I'm just going to go to 1 million. Dook, dook, dook. 1 million. Oh, wait. Whoa, wait a minute. Oh, shoot. I accidentally did 10 million. All right, I got to take one away. I just want to do 1 million for now. Did you guys see how many rolls it took? Look at that. 24 million rolls. Okay. So 1.7 million. Check this out, you guys. My computer just did 1.7 million random numbers, and how long did it take? 0 seconds. So did it actually take 0? No, it was 1/10 of a second, probably, somewhere in there. Okay, but my computer is so powerful that it can kick out 1.7 million random numbers in essentially instantly. Yeah, it totally does. So how fast these computers are, these are actually pretty powerful computers as far as the school goes. These are the nicest computers in the school. Okay, but here's the thing. What if I go ahead and change this to 1 billion? 1 billion would be 9 zeros. So it's going to run 1 billion. What's going to happen? It is actually going to take longer. So it's running. Okay, so it took 3 seconds. Well, sometimes it might kick it out pretty fast and you might get lucky. But that one took 0 seconds. That one took, wow, that was super fast. 14 seconds. Yeah, look at this one. This one's taking way longer. Come on. Come on, you can do it. Hey, there we go. So that one took 11 seconds. How come 1 million takes 1/10 of a second and 1 billion takes 11 seconds? Why is it so much longer? Okay, human brains are actually terrible at figuring out or thinking about what large numbers actually represent. We can't quantify in our brains. We're just not very good at conceptualizing big numbers. Let me give you an example. 1 million $1 bills. Okay, so if you have 1 million $1 bills stacked on top of each other, the flat way, not the tall way. Remember, we talked about this. 1 million $1 bills was the height of the Empire State Building. 1 billion $1 bills is 67.5 miles high. Think about the difference between that. Okay? So what we're asking the computer to do at this point is actually significantly higher. Josh? Okay? Okay. Okay. 1 million seconds was 11 days ago. Okay. So 1 billion seconds was 32 years ago. Oh my gosh. Okay. my gosh. A quintillion seconds ago, the universe wasn't even a thing. Okay. All right. You guys got this okay? Yeah. His literally, okay, what happens if I go too far? If I go to 10 billion, all of a sudden it kicks out an error and it says what? Integer number too large. How large can I go? Well, it turns out that a safe number for you guys to go to is about 2.1 billion. 2.2 billion is too big. It's in the 2.1 billion range. So I can run that. Why are we limited to 2.1 billion? Well, that's the memory allocation for an integer. I will teach you guys how to declare things longer than that. As we go further down the road, we can use something called a long instead of an integer. It's basically the double version of a float that you guys already understand. Okay? All right. You guys good with this? We cool? Okay. All right. So that's the end of our video. Say hi to yourselves, I guess. I don't know. Hi, Amy. Amy says for Amy to have a good day. Yeah. Okay. Yeah, don't forget to smash the subscribe. No, like. Smash the like. Smash the like. Smash the like and subscribe and turn on notifications so the next time you get a video, yeah. Some of you guys may have accidentally found your way into my motorcycle videos. Just, pretend I didn't swear in them. And I almost got ran over. Just saying. Okay, that's it. See you next time.